Okay, so let's look at a few of these secant and cosecant examples. We looked yesterday at the basic secant, cosecant graph. My VidQ shut down overnight too, so I don't have those anymore. But let's go through some basics. Just a little more practice with phase shifts and periods, I think is what we need, right? Just how we do those basics. So, okay, information is still the same. If it's not ingrained in your brain yet, then you're going to have to flip back to the sine and cosine page. But hopefully it's getting to the point where it's ingrained in your brain and you know how to define everything. So number 1, my center line is 1. My amplitude, excuse me, amplitude is 5. What's that negative out front mean? Yeah, there's going to be a reflection across the x-axis. If there's a reflection, it's always across the x-axis with what we're doing. What about a period? How do we find the period? Okay, 2 pi divided by b, and b is 2, the number in front of x. 2 pi divided by 2 is pi. And phase shift. Remember, phase shift is c over b. It's what's in that parentheses. So my c over b is going to be pi over 2. Opposite the sign, so it will be right pi over 2. Okay, so we're masters at doing that. I think most of you guys were writing that down on the worksheets, which was good. This was never the issue, is finding the information. The issues happen later on with labeling and whatnot. Okay, you got your center line of 1, amplitude of 5. Remember, I don't encourage you to go all the way up or all the way down because we have to have room to flip our curves. Okay, and I know they're small. So if I'm going up to 5, 1 plus 5 is, if I'm going up 5, 1 plus 5 is 6. And if I'm going down 5, 1 minus 5 is negative 4. Okay, I have a period of pi. So I have to graph at least over to pi. What's the midway point of pi? Pi over 2. Now, as I pause right here to think about that, keep in mind we also are going to have to consider a phase shift going right pi over 2. So keep in mind, right now my graph ends at pi. If I'm going to go right pi over 2, I'm going to need to go another pi over 2, aren't I? So we're going to have to label out to what is another pi over 2? 3 pi over 2. Maybe not precisely, but can you tell my sections are kind of equal? Maybe, hopefully. Okay. Now, again, my graph, my original graph without phase shift goes from 0 to pi. Right now I have 0 to pi broken into 2 sections. I'm going to take it and break it into 4 sections. So basically I'm going to take each of these pieces and mark them in half. Excuse me. So I put a tick mark in each of the middles. So between 0 and pi over 2, pi over 2 and pi, pi and 3 pi over 2. If you want to label them, they're fourths. If you want to leave it like this, you're fine. Okay. We never talked about it. What are we graphing here? Cosecant is the reciprocal of sine. A normal sine graph starts at center, goes up, then down. But this is a reflected sine curve, so we're actually going to start at center, go down, then up. Right? Okay. My choice of teaching method is, okay, I'm going to graph the original and then I'll shift it. So if I'm graphing the original, keep in mind, I'm only going over to pi, right? My period is 0 to pi. So my sine curve, my reflected sine curve, has to fit from 0 to pi, which means I start at 0. I'm going to go down below the first tick mark, cross through pi over 2, up above the next tick mark, and then cross through pi. That's my sine curve, yes? And this is my before I shift. So you just see me kind of tracing this in gray. But we still have to consider the shift. The shift moves everything pi over 2 to the right. So instead of starting at 0, we're going to start at pi over 2. Basically, everything's going to move 2 tick marks in this case, if you will. So now, instead of being below in between 0 and pi over 2, now my min is between pi over 2 and pi. Instead of crossing through pi over 2, my middle is crossing through pi. Instead of my max being between pi over 2 and pi, it's between pi and 3 pi over 2. Instead of ending at pi, I'm ending at 3 pi over 2. Do me a favor, try and keep your maxes and mins at the height of, I don't like that one seems too high, at the height of what you're labeled, right? So my mins and maxes, my mins should be at -4, my maxes should be at 6. Okay. Notice my sine curve is still a dotted line. And the reason I did my sine curve is still a dotted line because am I graphing sine?
No.
No, this graph is technically cosecant. And so the cosecant graph is just the parabolas. The sine curve is to help us position it. That's the only reason I put the sine curve in there is to position it. If you graph cosecant on your calculator, it is just the parabolas. I think I did that for this class yesterday. Okay? So that green is my sine curve. And I'm going to use it to position my cosecant curve. So every place there's a 0 on sine, it becomes an asymptote. So I have an asymptote at pi over 2. I have an asymptote at pi. And I have an asymptote at 3 pi over 2.
There's so many dots.
There are a lot of dots.
Oh, okay.
There's a reason I'm color coding up here. Okay. All we have to do is put the parabolas in. Between pi over 2 and pi, the bottom of my sine curve is that valley, so I'm going to take that valley and flip it upside down, and it's the parabola. It's an upside down parabola. Between pi and 3 pi over 2, there's the mountain up there, so when I flip that upside down, it's a right side up parabola. Make your parabola a size appropriate to how far your asymptotes are apart from each other. Is that okay? Okay. Shall we try 2? Feel free to move if you need to move. Is it just the dots that are hard to see and everything?
I can't really see the color difference that much.
Okay.
It's a little bit.
Yeah, I say feel free to move to get where you need to be so you can see. To me, it all looks perfectly fine, but I'm right on top of it too, so. Okay, number 2. I don't know that you guys really need me for the beginning part. Oh, by the way, on number 2, squeeze your stuff as far over left as you can. Our shift is going to take us left, and I usually end up extending that graph a little bit to the left. Just an FYI. You guys like when I tell you this stuff ahead of time, right? Because you like to be able to plan. So I'm trying to help you plan. At least if this is, yeah, this is the one where I end up extending my axis to the left. So, okay, my center is negative 2.5. My amplitude is 0.5. Reflection? No. What about a period? 2 pi over b, which is 4. 2 pi over 4 reduces to be pi over 2. And a phase shift, c over b. So it's going to be the negative of 4 pi over 4. Did we say negative? Which ends up being negative pi. Okay. So that shift of negative pi is why I was trying to warn you that we're going to have to, I end up extending my x-axis. Choose to do it how you will, but I extend my x-axis. Okay. Get your center line and amplitude on there, yes? Center line of negative 2.5. Amplitude of 0.5. So going up 0.5 is going to put me at negative 2. Going down 0.5 puts me at negative 3.
Will we ever have a phase shift up or down?
Our phase shift up or down is our center line changing. Like this graph is technically moving down 2.5 units because the center line is moving to negative 2.5. So we are shifting up and down, but it's a little bit easier. Okay, let's see. We have a period of pi over 2, yes? So as I label this, I need to label pi over 2. Now, I'm not going to make my pi over 2 huge here. So a period of pi over 2 says my whole graph has to fit between 0 and pi over 2. That's my whole graph. It's between 0 and pi over 2. But then we're going to end up having to shift it left pi. So if we start labeling left pi, okay, so here is 0 to pi over 2, correct? Now, to the left, I would mirror this. If this is pi over 2 to the right, can you mirror it to the left? And easier said than done. That's approximately negative pi over 2. Keep in mind, I'm going to have to go negative pi. So how far is negative pi? That's another pi over 2, isn't it? So what I would do is kind of then double that area and make my negative pi over there. That would be my suggestion. And so now I'm set that in the end I can shift it. From 0 to pi over 2 is my period. Okay. First of all, this period, I only have one thing right now. So I need to break it in half. What's half of pi over 2? Pi over 4. If I break these pieces in half over here, Over here is a negative pi over 4. And then what's the fourth that's between negative pi over 2 and negative pi? And that's a negative 3 pi over 4. Technically, I still need a set of tick marks. Because, look, from 0 to pi over 2, how many pieces is this broken into? 0 to pi over 2, which is my period, only has 2 pieces. So I need tick marks in the middle of those. That way I have my 4 pieces. If I have tick marks in the middle of those, guess what I'm going to do? Basically, I'm putting a tick mark in the middle of everything. And those tick marks are technically 8s, but okay. With this in mind, not graphing the shift yet, just the period. The period goes from 0 to pi over 2. So if I'm going from 0 to pi over 2, okay, wait, back up. What am I even graphing? Did anyone consider that? It's a secant, so we need a cosine curve. I keep skipping over that, but when you hit that point, you have to go back and check, don't you? Okay, so a cosine curve, if I'm just going from my regular period 0 to 2 pi, it says I start high, cross through, have a minimum, cross through, end high. So I have a maximum. So my cosine curve looks something like that. Okay. Now, with that in mind, what about my shift? Shift of negative pi says my 0 here, what started at 0, is now going to start over at negative pi. So we're going to start up there above negative pi. I ended at pi over 2 here. So where am I going to end when I move that right or left pi? I'm going to end above negative pi over 2. So those 2 dots I put in there, those are my starting and ending points, if you will. Can you make your cosine graph happen between there? If I give you a starting and ending point? Because it's broken into my 4 pieces, right? So I have my max. I'm going to cross through. I'm going to have my minimum. I'm going to cross through. And I've got my max again. At least all the dots are separated this time. Now, that purple graph is where it actually ended up. Interestingly enough, if we actually connected this and the original graph, realize it's the same graph. Our phase shift landed on top of itself. Sometimes it happens, sometimes it doesn't. And this time it did. So remember, zeros become asymptotes. So I'm going to have an asymptote between negative pi and negative 3 pi over 4. And between negative 3 pi over 4 and negative pi over 2. That is going to be a lot of dots, isn't it? Okay. If we start right here in the middle of my 2 asymptotes, this valley flips upside down and becomes an upside down parabola. So you need that middle parabola. And then, what do you have on either side? Here at this max over here at negative pi, officially, all you have is half of a parabola. That's officially all you have to put. On the other side at negative pi over 2, officially there is half a parabola. But I talked yesterday, didn't I? I always need you to have the equivalence of two parabolas. When you have a cosecant with a sine curve, that's easy. It's two full parabolas. With a secant and a cosine curve, it's one full parabola and two half parabolas. Now, if that bothers you to have the half parabolas, can you go ahead and continue them and make them full parabolas? Yes, you can. Okay. And so that is, oops, that one ended up a little wider than I wanted it. You can, if you prefer, make those three full parabolas. Just make them appropriate size. And I know some of you walked in the middle of that one. So I would definitely say, on the next one, you can start from the beginning with us. Ask questions if there's questions I need to go back and explain here. My plan, do I have time, was to do number 3 on the back. It's doable.
Thank you.
Did you have the sine and cosine yet either?
You handed these out Friday, didn't you?
I don't think I handed them out till Monday.
I thought we might have been able to do one when
Yeah, you
you
gave
handed
it
it
to us
out
Friday.
Friday.
Oh, did I?
But I might have it. But if I don't, then I'll have it.
Do you have it now? Okay, let's try and go through number 3 here. And I can always come back to this page at the end. Okay. Starting fresh with everybody, right? Number 3. Pieces are the same, right? Where's my center line? Center line is over here at the end. There is nothing, so it's a 0. Amplitude. It's a number out front. It is 4. It is a positive 4, so that means there is not a reflection. Period. Sorry, I had a moment of what am I doing next? Okay. It's 2 pi divided by b. B is the coefficient of x, and this is x over 2. If that is x over 2, what's that invisible number in front of x? A 1, and thus it is the 1/2. Okay, so since it's x divided by 2, think of it as 1x divided by 2, and think of your b value as 1/2. We did this the other day. 2 pi divided by 1/2 is 2 pi times 2 over 1. And 2 pi times 2 over 1 is 4 pi. So we're going to stretch this one way out. No, we're okay. We don't need a bunch of space on this one. Phase shift. Phase shift is C over B, opposite the sign, so it's going to be negative pi over 3 divided by 1/2. So negative pi over 3 dividing by 1/2 is multiplying by 2 over 1. So we have a phase shift of negative 2 pi over 3. Which sounds bad, but with such a big period, a long period, it actually works okay. Okay, so I'll take you through that when we get there. We're okay with that information, right? If you don't remember, all that information is the same information from sine and cosine, so go back to that lesson. Okay, let's see. My center line is 0, an amplitude of 4. So that means I'm counting up to 4 and down to 4. Got the easy part, right? What's a period of 4 pi? 4 pi means I'm going to take my line, I'm going to take my graph all the way out to 4 pi. Break it into 4 pieces, yes? The middle of 4 pi is 2 pi. Make those symmetric. The middle of 0 and 2 pi is 1 pi. The middle of 2 pi and 4 pi is 3 pi. I have this set up 4 sections, yes? Now, before I throw in the extra tick marks, I'm going to say, let's go ahead. Can you go ahead and graph whichever curve it is we need? Am I graphing sine or cosine here? Okay, because this is cosecant, we are graphing sine. It's a regular sine, yes? So if I'm graphing sine, sine what? Starts at the center, has a max above the first mark, cuts through the middle mark, has a min at the last or the third mark, and cuts through the last mark. Does that make sense? Starts at 0, max above pi, cuts through 2 pi, min under 3 pi, cuts through 4 pi. Now, what's the catch? Phase shift of 2 pi over 3. Now, the nice part is about this one, I promise this one works out nicely. My graph right now is just broken into whole pies, yes? It's pretty easy to put thirds on here at this point. Because what do you know, like for instance, 0 to 1 pi. What can you break that up into? I can break that up into thirds, yes? To break it up into 3 pieces, I put two tick marks in there. And the idea is that first tick mark is pi over 3. The second tick mark is 2 pi over 3. Those are the size marks I need. Am I making sense here? So between 1 pi and 2 pi, I can put 2 tick marks. Between 2 pi and 3 pi, I can put 2 tick marks. Between 3 pi and 4 pi, I can put 2 tick marks. So I've taken all my whole pies and broken them into thirds. Now, only thing I haven't done, we're shifting left, yes? Make equivalent marks. You see each of these marks represents a third, yes? I need to have negative 2 pi over third. So the first mark I'm going to make is negative pi over 3. The second mark I'm going to make is negative 2 pi over 3. If you want a third mark, it's negative pi, but we don't really even have to go to negative pi. Okay, you ready? Everything I do has to go 2 pi over 3 left. 2 pi over 3 left is how many tick marks? 2. So it was starting at 0. Now it's starting at negative 2 pi over 3. There was a max above pi. Where do I move that? Now we're going to have a max above pi over 3. I'm moving everything back 2 tick marks. It was crossing through at 2 pi. Now I'm going to move it back 2 tick marks, and I'm crossing through right after pi. I did have a minimum under 3 pi. Now my minimum is going to be underneath what's right after 2 pi. We did cross through at 4 pi. Back it up 2 tick marks. Does that make sense? For me, I'm connecting my orange marks to make my appropriate sine curve. Zeros become asymptotes. And in the middle, I have a parabola going up, or on the left, I have a parabola going up above pi over 3, and I have a parabola going down over here. Okay? No, you guys are fine. I'm just making sure. Get that graph. Those of you that walked in late, okay? I handed back the sine cosine worksheet so you can see how you did. If you didn't miss any points, do double check, make sure I didn't write anything on it, because what I wrote on there, it could have been something that I was, I didn't count off for, but I was concerned. I wanted to make sure you saw what needed fixed, okay? See what you can do with them. This video will be online later if you want to go back and see some of the other examples, especially if you walked in later, okay? I know everyone was different rates today. Everyone has a secant cosecant worksheet, correct? Okay. Let me know what questions you have and all of that, and we'll talk later.
It's due tomorrow, right?
Yeah, we'll go over, it's due tomorrow, but yeah, we'll go over questions. Does that make sense?
Yeah.
Try it, see what you can do with it, but we will go over questions.
Thanks for the cheese.
You're welcome.
Go to the worksheet.